All right, two other properties of logarithms. Really what these say is, this comes from the fact that this is a one-to-one function. Um, and essentially what this first line here says, if m is equal to n, then log base a of m is equal to log base a of n. And what that says is you can take the take the logarithm of both sides of an equation. So just like you can square both sides of an equation or add 3 or divide by 2, you can actually take the logarithm of both sides. That's a perfectly legal move. The same thing here, just going the other way. If you've got log base a equal to a log base a, you can drop the logarithm notation and just say m equals n. So these are really helpful when it comes to solving some logarithmic equations. We'll get to that more in the next section, but one thing that we can kind of look at now is how we could use that to approximate log base 2 of 7. Alright, so how do we approximate that? Notice we can't really use a calculator to do it. So yeah, how do we do log base 2 of 7? You know, we don't have a log base 2 button on our calculator, so we can't really go that route, but we can start by maybe rewriting it as 2 to the x equals 7. And then let's take the natural logarithm of both sides. Now that doesn't seem to be really helpful yet, but if you'll remember, what we can do now is we can pull this x down, right? And say this is x natural log 2. And now since that's just x times natural log 2 is just a number. So let's divide by natural log 2 and get that x is natural log 7 over natural log 2. Well, how about that? I can take this, right? Notice instructions said to get a decimal approximation round to 4 decimal places. I've got a natural log button on my calculator. So I just need to know what's natural log 7, close the parentheses, divided by natural log 2. That is 2.8073. So there's something new. Okay, we couldn't really do that before, but knowing that we can take the logarithm of both sides, that's what really allowed us to unlock this equation and solve for x. Because once we did that natural logarithm, we could pull that x down and then solve for it. And that's a really critical piece there. That's a trick that's really handy when you get into solving logarithmic equations and exponential equations. We'll see that more in the next section. Now, what that really leads into to finish out this section is what's called the change of base formula. And really, if you look at what we did, we took a log base 2 of 7 and said that was the same as natural log 7 over natural log 2. Said those were equivalent, right? And really, that statement is true for any base logarithm. That's what this change of base says. If you have a base a logarithm, you can rewrite it as 2 other different base logarithms. So a base a could be written as a quotient of 2 base b logarithms. So in other words, log base 2 of 7 we said was the same as natural log 7 over natural log 2. Notice the m goes here and the a goes here, just like the 7 went here and the 2 went here. That's also the same as, we could say that's common logarithm, base 10 of 7 over log base 2. Or we could say that it's log base 6 of 7 over log base 6 of 2. Doesn't matter what the base is, as long as we put the 7 here and the 2 here, and these two bases match. Okay, but the way this is really useful is these two guys right here, because those are on the calculator. So where before we couldn't do a base 2 logarithm on the calculator or a base 7 logarithm, using this change of base formula we can rewrite into a natural logarithm or a common logarithm, and then go to the calculator and punch it in and get a decimal value. That's something we need. And so let's kind of practice using that. That's what this right here says. These are really the two ways you'll see the change of base formula used more often than not, is with a common logarithm and a natural logarithm. But just practicing this a little bit, use the change of base formula and a calculator to approximate each logarithm, and round your answer to 3 decimal places. The way that's going to work, log base 5 of 89, you can say that's natural log of 89 over natural log 5, or log 89 over log 5. Either one of those works. We can go to the calculator and say natural log 89, make sure you close your parentheses, divided by natural log 5. Whoops, actually didn't close my parentheses there. That's, let me make sure it doesn't change the answer in this case, but it's a good habit to get into. So you get 2.7889. Again, if you do a base 10 logarithm, you should get the same answer, right? It doesn't matter what the base is. 2.7889. This is round to 3 decimal places. Okay. Here, log square root 2 of square root 5. Okay, just rewrite it using change of base. Either base works. As long as you put the square root of 5 on top and the square root of 2 on bottom. Alright, now this is a little trickier because of the square roots. I would suggest maybe going this route and saying natural log square root of 2 sorry, should be a square root of 5 on top, right? So let's start with that. Natural log square root of 5, you can actually punch that in first, and then hit divided by natural log square root of 2. And that'll maybe help you keep from getting your parentheses mixed up. We get 2.321, or 322. Okay. Alright, well that's the change of base formula, and that's the last piece of this section. And so we'll use a lot of this information, these properties, in the next section when we get into solving properties of logarithms.